All right, so let's say I gave you this. You have 2 point charges. One has a charge of 3 times 10 to the negative 6 coulombs. The other one has 4. Imagine that you have a point up here, okay? And you want to find the net electric field at that point, knowing that this imaginary line towards that point is 30 degrees. This point over here, imaginary line is 40 degrees. One distance is 0.5 meters, the other one is 0.8. Okay? Now, here's the deal. We're not going to go through it, but let's just talk about the process. Okay? How are you going to solve the problem?
Components.
No. First, you have to figure out what's going to happen. What's the big picture?
Oh.
So if you have a positive test charge here, what's it going to feel from this one?
Repulsion.
So it's going to feel a repulsion going this way, right? And this one's going to also feel repulsion, right? Now, can you find the net electric force at that point?
No.
Absolutely not. You cannot. Why?
So you don't have the charge of that.
I don't know what the charge is there. Can I find the value of the electric field?
Yeah.
All day long. Okay? I can find the net electric field. Now, what are you going to, so to get this particular value of that repulsive force going in that direction, you know the charge and you know the distance. So how are you going to get that?
KQR squared.
F is going to equal KQ over
R squared.
D squared R squared, whatever that's going to be, right? So this is going to get you some value. You need the same thing over here, right? Oh, I'm sorry, electric field. I left off an E. So the E is going to be K distance over, okay? So remember, that's going to represent which side of the triangle? The hypotenuse, right? That's going to represent the hypotenuse. Now, once you get that, then you can find the X and Y components of each one. Right?
Go against it.
They will probably not.
The left one.
So here's the story. So when you look at this, are the X's automatically going to cancel?
We can't assume.
No, you cannot assume that the X is going to cancel because this thing isn't symmetrical. Now, if both charges were the same and both distances were the same, hey, the X's would cancel out. You don't have that situation. But here's the bigger thought, is that are the X components going to have opposite signs?
Definitely.
Yeah.
Yeah, so if you were to set up a chart, you go, okay, here's that 4 coulomb, here's that 3 coulomb, and here's the sum. X and Y components. So the X component from the 4 times negative 6, is that X component from that one going to be a positive or negative value?
Which ones?
From this 4 nano, from this 4 coulomb charge,
Negative.
up there, is that X component going to have a positive or negative charge?
Negative.
Negative. Okay? But the 3 component is going to have a. So, do you know the sign of the overall X component? You don't know, because you don't know which one's bigger or smaller. Okay? But you got to figure it's not probably going to be very big. Okay? Because one has a bigger charge, but it also has a bigger distance. One has a smaller charge with a smaller distance. Okay? Now, what about the Y component? Both of those are going to be positive values. Okay? So you know that the sum of your Y components is going to be some positive value. So here's your 2 options. You could have a negative X, you could have a positive X with a big positive y. And what would that angle be less than? 90. Okay? The other option is that you have a negative x with a positive y, and that would produce some angle greater than 90. Okay?
Oh, I see.
So there's no shortcut way around it. That's just what you have to do. Okay? You've got to break it up into the x and y components and then find the sum of those values. There's no like cute shortcut method. What?
Can I get the restaurant?
Let's go
I
through human resources.
think that's it. I'm done.
Dude, let's Jackie quick. Anyone do it?
What do you mean? I'm his favorite student.
Oh no.
How long is this? No, don't give me that smile.
Asbury, I gotta say for
Guys, we're good so far.
Brig, I got come home, right?
Yeah,
Can I borrow that ruler really quick?
Actually, it's one of my sister's PTs.
Yes.
Mike, can I borrow that ruler really quick?
It comes with the binder.
It's only 5.
Thank you.
Oh gosh.
in New York. She
Oh,
got
gosh.
EPA in Nashville.
What?
I'm heading down.
Yo.
I need you to do it.
Yeah, guys, I think this is part of it. I got 4th, but I get 30
Bert, can you hold off on this? I gotta go to Arizona during spring break.
Brig, I'm sorry.
Spring break is 3 weeks.
It hurts way more than it hurts you.
I have.
Brig, this weekend I'm busy.
At the casino.
23 to
I prefer on Sunday, 1 class.
Okay, that's it.
18 to 27?